In this video, we are going to learn on the empirical and molecular formula. Empirical, by definition, is the simplest or the smallest possible whole number ratios of all the atoms in a compound. So it is not necessarily represent the actual number of atoms in a molecule, while molecular formula indicates the actual numbers of atoms present in a molecule of the compound. So here we have the formula to calculate the molecular formula, which equal to, in bracket, empirical formula times or multiply by n. N is an integer, n can be 1, 2, 3, 4, 5, and so on. So example, here we have several different compounds that have the same empirical formula, which is CH2O. Okay, from the table here we can see that three different compounds with the same empirical formula here. Okay, CH2O. We don't know whether this formula is belong to acetaldehyde or acetic acid or lactic acid. So since we know the integer for each of the compounds is 1, 2, and 3, so we can just multiply the integer with the empirical formula. So we will get the molecular formula is for acetaldehyde is CH2O, and for acetic acid we have a C2H4O2, and for lactic acid we have C3H6NO3. The same goes for molar mass also, where we need to multiply the integer with the original molar mass 30. So we will get the molar mass according to the molecular formula. But we also can calculate directly the molar mass from the molecular formula here. Let's say here we have C3, so 12 carbon times 3 plus 6 times 1 for hydrogen plus 3 times 16 for oxygen, so we will get 90 gram per mole also. So we have another example here where a 0.648 gram sample of isobutene contains 0.556 gram of carbon and the rest is hydrogen. So 0.5 mole of the isobutene has a mass of 28.5 gram. So the question is, what is the empirical formula and the molecular formula of isobutene? So first thing first is that we have to extract the information from the question. Okay, the information given here, mass of isobutene equal to 0.648 gram. And the mass of carbon is 0.556 gram. To calculate the mass of hydrogen, we have to minus the mass of isobutene with the mass of carbon. So we will get the mass of hydrogen here is 0.092 gram. Then what we need to do next is that we have to tabulate the information in a table. So here we have the atom of carbon and hydrogen. So we have the mass of each atom, and we have to calculate the number of moles for each atom. So we have the formula of mass divided by molar mass. So we have the mass of carbon is 0.556 divided by 12. 12 is the molar mass for carbon. So we will get the number of moles of carbon is 0.046 mole. Okay, the same goes for the hydrogen atom, where we have the mass of hydrogen atom is 0.092 divided by 1. 1 is the molar mass of hydrogen atom, so we will get the number of moles of hydrogen atom is 0.092 mole. Next is that we need to compare both of the moles value and find the smallest mole values. Comparing both carbon and hydrogen, we have carbon, the moles of carbon is the smallest one, okay, 0.046 moles. So we have to divide by the smallest mole value to get the whole number ratio. Okay, so here 0.046 divided by 0.046, we will get 1 for carbon atom, and for the hydrogen atom 0.092 divided by 0.046, we will get 2 for hydrogen atom. So how we want to write the empirical formula for based on this value? So we will get carbon atom having 1 atom and hydrogen atom having 2. So here is the empirical formula based on this question. So how to find the molecular formula for isobutene? Okay, remember we have the formula here, molecular formula equal to, in bracket, empirical formula multiplied by n. Okay, n is an integer and equal to what can be 1, 2, 3 and so on. So the empirical formula for isobutene we already got, and that is CH2. And the molecular formula for isobutene is that we have to put in bracket CH2 and times by n. So we don't know the value of n. So what we need to do next, that we get the information from the question where the 0.5 mole of isobutene has a mass of 28.5 gram. This value represents the actual mass of the isobutene based on the molecular formula of the isobutene. So what we need to do is that we have to find the molar mass of isobutene. So here mass over moles, okay? So when we divide the mass of the isobutene with the moles given, so we will get the molar mass of isobutene equal to 57 gram per mole. Next is that we need to find the value of n. Okay, since we know the molar mass, the actual molar mass of isobutene is 57 gram per mole, so we do this calculation by equal to CH2 multiplied by n times by n. So we know the molar mass for CH2, the empirical formula is that 12 for carbon plus 2 times 1 for hydrogen, so we will get 14. So what we need to do is that we just substitute the value inside the formula here, so we can get the value of n equal to 4. So what we need to do after this, so we need to times, okay, 4 times the empirical formula for we get earlier, CH2. So this one is the molecular formula for the isobutene.